Okay, class, so here we are in our example number 11, where we are given here a needle. A needle which is 35 mm long. Okay, take note the length is 35 millimeters. And we are also given the temperature, which is at 20 degrees Celsius. Take note, class, the fluid is in the water. Okay, it is in the water floating, and we are asked what is the force over and above the needle. Take note, above and over, which means that there's force or there's resistance. If, for example, this is our water, okay, or yeah, this is our water there. Okay, this is our water, and this is our needle. Okay, let's say this is our needle floating there. So from that, there's a force over and above there. Okay, so we are asked what is this force here over and above the needle's weight required to lift. Take note, lift. So isa lang pala, isa lang. Kasi over and above, which means nasa taas lang pala siya. Oo, ayun. Yeah, to lift the weight of the needle from contact with the water's surface. Ayan. Kasi floating yung natin yung needle natin. So, if you could recall, okay, in order for us to solve for the force, okay, force, we are given the formula of a surface tension, which is sigma is equal to change of force or over change in length. So therefore, from here, we may be able to solve for the force by simply multiplying your surface tension times your length. Okay, so we are given here the length, but of course we have to convert first our millimeter to meters. But then, class, do we have a value of what do you call this? Of surface tension? If you could recall, if you open your module on page 4, we have there value of surface tension of water with air, which is, if you can see here, 0.0756 Newton per meter. But take note, class, that the value or the temperature should be at 0 degrees Celsius. But then the given here is 20 degrees Celsius. So we cannot use the 0.0756. But rather, class, if you search from the internet the value of the surface tension of water at 20 degrees Celsius. Okay, so the value here, if you search in the internet, is 72.8 millinewton per meter. Okay, so this will be the value that we will be using here in our formula. So 72.8 milli is times 10 negative 3 Newton per meter times your length, which is 35 times 10 negative 3 meter. So we can cancel out meter here and we will be left by the unit Newton. So from here, class, we have 72.8 times 10 raised to negative 3 times 35 times 10 raised to negative 3. So that is, we have here 2.548 times 10 negative 3, and the unit is Newton. And that's, class, that's it, the required force just to lift your needle to float in the water.